Hi guys, this is Miss Gold. Today's lesson is Module 1, Lesson 5, Operations with Numbers and Scientific Notation. Your outcomes for today's lesson are students practice operations with numbers expressed in scientific notation and standard notation. So let's take a look at example 1. The world population is about 7 billion. There are 4.6 times 10 to the 7th ants for every human on the planet. About how many ants are there in the world? Now, when you're interpreting these problems, the most difficult time that people have is actually just with figuring out what operation do I need to do here. So if you think about it, if there are 4.6 times 10 to the 7th ants for every human, well, what if we thought about changing every human to one human? Okay, so we know that every means one. So what if there were 2 humans? What would happen to the number of ants? Well, that would actually double. What if there were 3 humans? It would triple, right? And then if there were 4 humans, it would quadruple. So essentially what you figure out by just thinking about this basic stuff is you figure out what we're actually doing here is multiplication. So that tells me that I'm going to take the number of ants and multiply it by the number of humans. And so that gives me an idea of what I'm going to do here. So notice here what I'm trying to start with is an operation that involves words, so it connects it to the context of the problem. Then I can change those out for the numbers. So we know the number of ants is 4.6 times 10 to the 7th. And we're going to multiply this by 7 billion. So 7 billion, we would start with thousands, millions, billions. And as we learned yesterday, we need to either work in all scientific notation or all standard notation. So why don't we change our 7 billion to scientific notation? So I know my number is going to be 7 because everything else is zeros. So if I had to move it over, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9. So times 10 to the 9th power. So when I'm multiplying scientific notation, I'm actually going to use the commutative property of multiplication to rearrange these and group my like items together. So we're going to use the commutative property. And when I do that, I'm able to rearrange them. So let's actually switch these two. That will give us 4.6 times 7 multiplied by 10 to the 7th times 10 to the 9th. And if it helps, you can group these two together, and that's the associative property. So if I multiply these, 4.6 times 7 is 32.2 times. We know from our exponent laws that if I'm multiplying the same base, I would keep the base and add the exponent, so this would be 7 plus 9. And I need to put this into scientific notation, so let's start with what our number should be. We know that 7 plus 9 is going to give us 16, but notice I also had to move this over 1. So if it helps here, let's just write a little 16 here. And then I had to add 1 to the exponent because I had to move it over 1 place. So 3.22 is going to be my number out in front. And then instead of 16, we're going to go with a 17 because I moved it over once. Now, this number, you'll notice, is a really, really large number. So you certainly don't want to take this and turn it into standard notation. So this is the kind of things that I would think about when I'm answering these questions. If they don't specifically say put it in scientific or standard notation, you want to think what's the most logical answer here. It certainly isn't logical for me to move my decimal over 17 times. That's a lot. So my final answer here is going to be 3.22 times 10 to the 17th ants in the world. Okay, notice I gave a worded answer to give the context of this word problem. Okay, let's take a look at example 2. A certain social media company processes about 990 billion likes per year. If the company has approximately 8.9 times 10 to the 8th users of social media, about how many likes is each user responsible for per year? Write your answer in scientific and standard notation. So the first thing I need to decide here is, what operation am I going to be using? And what really tells me and gives me a hint about it is the fact that they say about how many likes is each user responsible for per year. So let's highlight that. So they're saying we have a whole bunch of likes for a whole bunch of users. How can I reduce that? Really what I'm looking for here is a unit rate. So if I want to get a unit rate out of this, notice how they said about how many likes per user. So it would be the likes on the top and the users on the bottom. So this tells me I am going to be doing division if I'm trying to find a unit rate. So first, let's take our likes on the top, and the likes are 990 billion. So we'll write our 990, followed by, let's see, thousands, millions, billions. And then on the bottom, the number of users they gave us was 8.9 times 10 to the 8th. And we certainly don't want them to be in a different form, so let's turn our top number into scientific notation because it's a very, very large number. So looking at this, I know my decimal should go here because 9.9 is between 1 and 10. So 9.9 times 10 to the power of, let's count out how many times I'd have to move it. Well, I'd move it 3, 6, 9, 10, 11 times. And then we have our bottom number is already in scientific notation. So when I'm dividing, kind of similar to the multiplying, I'm putting my like things together, such as my regular numbers. I'm going to just divide those. So divide here. And then here, I have powers of 10, so I'm going to use my exponent law here for division. So when I divide those, I do 9.9 divided by 8.9, and you will actually find when you do that on your calculator, you're going to get a really long decimal. So what we really want to notice here is that they actually stated about how many. That really tells me that they're asking me to estimate. So if I'm going to estimate this, I'm going to say it's approximately 1.11. Then we can use our exponent laws to figure out the second portion here. So 10 to the 11th divided by 10 to the 8th, we keep the base and subtract the exponents. And so that's going to give me a final approximation of 1.11 times 10 to the third. And what I should actually correct here is, if we're finding an approximation, this wouldn't be an equals. We would actually use the approximation sign, which is a squiggle equals. And they want the answer in both scientific and standard notation. And this is a reasonable thing to ask because you'll notice here the exponent is 3. I only have to move it over 3 times. So we'll say or 1, and then I move it over once, twice, 3 times. So this is about 1,110 likes per user per year. Again, I'm putting the context of the situation into my final answer so it relates it back to the actual question. Okay, let's take a look at example 3. In 2010, Americans generated about 2.5 times 10 to the 8th tons of garbage that is sent to landfills, while the rest is recycled and composted. There are about 2,000 landfills in the United States. Assuming that each landfill is the same size and that trash is divided equally among them, determine how many tons of garbage were sent to each landfill in 2010. Now, one of the big clues here is they actually say the trash is divided equally among the landfills. So that really tells me that what I'm doing is I'm dividing the tons of trash by how many landfills there are. Again, it's similar to our previous question where I'm trying to find a unit rate. how many tons of trash are being sent to each one of the landfills. That's a unit rate. So this would be tons of trash over the number of landfills. So let's start with our number. Americans generated about 2.5 times 10 to the 8th tons of garbage. And we're going to divide that by 2,000 because that's the number of landfills. So again, we need to turn this back into scientific notation. So I know this would be 2 on the bottom times 10 to the power of, let's say we move over 1, 2, 3 times. Number on the top is the same. Okay, and again, I'm going to break this up and divide my 2.5 by 2. When I do that, I get 1.25 times 10 to the power of, again, I am dividing my bases, so I subtract my exponents, so this would be 8 minus 3, and that will give me a final answer of 1.25 times 10 to the 5th. Now, this is a fairly small exponent, so I would say it would probably be very reasonable to just turn this into standard notation. So I'm basically going to move my decimal over 5 times, so that would be 1, 2, 3, 4, 5, put in my comma, and we'll put the context in the situation. So this is tons of garbage per landfill, and this was in 2010.